All right, so molarity. What is my equation for molarity? Moles over liters. That is important to know today. Moles over liters. Okay? All right, so let's say I have 3 moles of lithium. In a 5 molarity solution. How much liters was added? Okay, so we had a problem like this yesterday. 3 moles of lithium in a 5 molar solution, all right? And the reason I'm showing you this is because it's going to show up in your activity today, all right? So 3 moles, all right? So I can just get rid of my moles and put 3. Molarity, I have 5. How can I solve for L? Multiply by 3?
No, that's for the bottom one. Never mind. That's when you have to find the moles.
Jackson? Divide 5 by 3. How would you do that?
I don't know. There's like not steps to it.
So the opposite of division is multiplication. So you multiply by a third, and if you multiply by a third, you divide by 3, right? Okay. So let's say we do that. That's 1 over L. That's not L. How would we do that?
3 divided by 5.
3 to 5. How did you get there?
You like reset.
You want me to reset? I'll reset.
No.
Wait.
Okay. How do I solve L?
Yeah.
L's in the denominator. How do I get it out?
You can multiply L on both.
Oh, I like that. I'm going to multiply by L on both sides. Okay, now it's in the numerator. I like that. All right, so I have L times 5 equals 3. How do I get rid of the times 5? Bada bing, bada boom. There's your answer.
Yay.
All right?
I was kind of close.
Yeah, absolutely. Okay. Hopefully that's kind of familiar. All right. Now, the reason we're actually learning this is we're talking about molarity, all right? And moles over liters. Now, the molarity of each substance can be a little bit different. Okay? And I'm going to show you some examples here real quick, which is pretty awesome. And am I hooked up? Oh, my computer's about to die. That's what's going to happen. Technology, man.
Technology. Why don't they just make a battery then?
Who is?
No, why don't they just why don't they make a
You're
phone?
lucky. Mine sounds like an anvil when I throw it.
Have you ever seen
It sounds like I'm throwing an anvil up a 30-story
what's that called?
hotel.
Mission Impossible? It's a great show.
They should make a phone that's powered by the
Mission.
energy from the sun.
Mission.
That would be a good idea.
All right. Oh, that's not it. Here we go. You guys hear that?
Yeah.
I found out that in my first period class, I never knew this website had sound. Listen to this. It's the best thing ever.
Oh my god.
Now it'll be down really fast.
If you make music.
But watch this. It gets better. It gets better. I love it.
It's magical.
Love it. Oh, man. That made my day when I found that out. I was like, oh, this is getting awesome. All right. So there are 3 terms that you don't really have to write down right now because we're going to be discussing them today, probably next week, and for a little while. All right. So the 3 terms are known as saturation, saturated. The other term is going to be called super saturated.
If he wants to be
And
super. He wants to be
Go for a long
super
guess.
now.
Oh, we got a guess?
Not saturated.
Oh, what's it?
Unsaturated.
Unsaturated.
Wait, I got a guess for the next one.
Okay.
Oh, there's
So,
one.
those three terms, all right? We're going to see how they mix in with molarity. Okay? So, super saturated. I'm going to draw a beaker.
You should be an art teacher.
You know, I'm not a good artist, but I can draw a pretty good beaker.
Oh yeah.
That's pretty good, Mr. Rowers.
Thank you. Okay? So,
Wait, do you know who Mr. Rao is? A
Mr.
math teacher.
what?
Mr. Rao, a math teacher. Do you know him?
What's his
Might not.
first name?
I don't know.
I might.
Okay, so he made a perfect circle.
That's impressive. All right, so here we go. There's my water in each of them. All right, so what a super saturated actually looks like is you have some water in a beaker, you put some salt in it, you stir it up. What's going to happen?
It's gonna dissolve.
You're going to dissolve. All right, what if you put the entire container of salt in it?
It's gonna take a while.
It would like absorb the water. No, it'd be saturated. Be very saturated.
What you're going to start to see eventually is particles are going to start sitting at the bottom. Right? Because you're going to pour so much in there, there's no way you're going to stir in all that salt. No way. That's super saturated.
What if you get like a blender? Would that?
A whole package of salt.
Oh wait a minute, never mind.
Yeah.
What if it's like a package from McDonald's? You know, like the.
Hey, that's doable. Let's say you stir it in. You put some sugar or put some salt in your beaker and you stir it in. There's nothing on the bottom. That's unsaturated. Okay? You pour some sugar in, you stir it up, there's nothing unsaturated. Does anybody want to take a guess on what saturated is?
It's when there's only a few at the bottom.
I like that. I like that.
Kind of like what we did yesterday with the salt. Wait, never mind.
All right. So,
Everyone.
let's say like this line right here is the saturation point. Okay? So let's say I'm unsaturated. I add a little bit of salt. I move a little bit closer. I add a little bit more salt. I move a little closer. I move a little bit. I move a little bit. I am right at the line.
Oh, so
Right at that line is where you are saturated.
So you're adding just a little bit and a little bit more.
Exactly. And then when I add a tiny bit more, I'm super saturated. Saturated is the tiniest line. It is just the tiniest area you can be. Okay? So what I like to do is imagine just one dot. When you see one dot, you know that is saturated. Okay? So on this activity, can you guys see that all right? There's a lot. I'm going to pick a different color, actually. Oh, that was cool. Okay.
Oh,
Can you see all those dots at the bottom?
yeah.
I'm going to try to move these up and down to get rid of... Oh, I need... Oh, I heard a ting. I have one dot. That's saturated. Okay? So what's the molarity right there?
5. Oh no, it's the max is 5. It's 4.3.
4.350. And that is what we're doing. We're going to test the different molarities of different compounds. Okay? Just got a few questions to answer at the bottom about saturation, unsaturated, and then we'll be good to go. So what you're doing is looking at each one. So cobalt chloride, that's the one I'm on. What are the odds of that?
Very slim.
Very slim, right? Okay, so Cobalt chloride says, what is the solute amount that I added? How much solute did I add?
0.875.
0.875 right here. That's my moles. Remember, moles is solute. So 0.875. What was the amount of solution in the liquid? 0.2. Okay. And what was the molarity?
4.35.
4.35. Oh, wrong one. And that's what we're doing. Okay, that's what we're doing. Now, mathematically, does this make sense? If I have molarity is equal to moles over liters, my moles is 0.875. My liters is 0.2. Does anybody have a calculator on that? Can you plug those two in? 0.875 divided by 0.2.
0.2?
Yep.
4.375.
There it is. Oh, pretty close at least. There it is. All right, that's what we're doing. Does that make sense? Is there any questions right now? Maybe when we get started, might have a question or two. All right, so try working on this. All right, analyze a little bit about molarity. All right, if you guys have any questions,